Good morning. Today we are going to cover section 10.1, using fundamental identities. So take the time to copy your title, your essential question. How can we simplify expressions using trigonometric identities? Go and paste your cutouts, and we'll start once you are ready. Go and pause it. So we have covered reciprocal identities. We know that sine and cosecant are the reciprocal of each other. So therefore we can write sine of u equals 1 over cosecant of u. We know that cosine and secant are reciprocals of each other, so we can write cosine as 1 over secant, and tangent and cotangent are reciprocals of each other, so we can write tangent of u equals 1 over cotangent of u. Or we can write cosecant of u equals to 1 over sine of u, secant of u is equal to 1 over cosine of u, and cotangent is 1 over tangent. The quotient identities, we know that tangent is y over x, so therefore tangent of u is sine of u over cosine of u. Cotangent is x over y, so we can write down cotangent as cosine of u over sine of u. Now, let's go and make a right triangle on the left-hand side. Let's go and develop the Pythagorean identities. I'm going to place a right triangle on a unit circle. So I'm going to place my x and my y-axis. So this is a unit circle. And this is just the first quadrant. I'm not going to place a point somewhere. I'm going to place a 2, 3. Therefore, this is my angle. This is the x and y. So therefore, if I make a perpendicular line towards my x-axis, I'll make a right triangle. And this is my y value. This is my x value. And the radius or the hypotenuse is of length 1, since we're talking about a unit circle. So therefore, this is a right triangle. You can use Pythagorean theorem, which is x squared plus y squared is equal to 1. A squared plus b squared equal to c squared. 1 squared is 1. And for our previous definitions, we know that if it's a unit circle on less than 9.2, the sine of an angle is equal to the y. The cosine of an angle is equal to the x. So therefore, I can replace that x as the cosine square of x. And we can replace the sine of y, the y square, as the sine square of x. Or we can use u. Or we can use theta. In this case, they are using u, so let me go back and change it to a u, just to be able to be consistent. Or theta is fine. And I'm going to rewrite the sine goes first, plus the cosine square of u equals 1. And that's how we get our first Pythagorean identity. Now, I'm going to take this, and I'm going to write a bit smaller. I have sine square of u plus cosine square of u equals 1. I'm going to divide by the sine of u squared. So I'm going to divide both sides by sine square of u, sine square of u, and sine square of u. Therefore, sine square of u divided by sine square of u gives me 1, which is here. We know that cosine square of u divided by sine square of u, or cosine divided by sine, is cotangent. So therefore, this will be cotangent square of u. And we know that 1 over sine is cosecant, but because it's square, will be cosecant square of u. So this is your first identity. This is your second Pythagorean identity. And now we're going to prove the third one, which is here. I'm going to do the same thing. I'm going to write down the sine square of u plus cosine square of u equals 1. And now instead of dividing by sine square of u, I'm going to divide by cosine square of u. Sine square of u divided by cosine square of u will give me tangent square of u. Cosine square divided by cosine square gives me 1. And 1 over cosine, we know that is equal to secant. And now we develop all our first 3 Pythagorean identities. So you should be able to memorize this one pretty easy, correct? Sine square plus cosine square equal to 1. Now, if you forget the other two, you can go through the process and divide it by sine square of u to come up with the first one, and then divide by cosine square of u to come up with the second one. We also cover our cofunction identities on section 9.1, where we know that the sine and cosine are cofunctions of each other, correct? If I have the sine of 40 degrees is equal to the cosine of 50 degrees, correct? Because together, that gives me 90. We know that cosine and sine are cofunctions of each other, so therefore the cosine of 60 degrees is equal to the sine of 30 degrees. And if we type that into the calculator, which we've done before, right now I'm on radians, let me change it to degrees. The cosine of 60 gives me 0.5, and the sine of 30 will give me 0.5. The sine of 40 is equal to 0.64, so therefore the cosine of 50 will give me exactly the same. So we covered this cofunctions on 9.1, or is it 9.2? One of those, chapter 9. We know that tangent and cotangent are cofunctions of each other. Cosecant and secant are cofunctions of each other. So this is something that you need to keep in mind for some of the problems that we are going to be working. When we graph sine and cosine, we talked about sine being a odd function, correct? If you plug in a sine of negative u, you end up with negative sine of u. We know that cosine, so this is odd function. This is an even function. Cosine and secant are even functions, so the cosine of negative u is just basically the cosine of u. And the odd function will be for tangent. So something to keep in mind as we go through some of the simplification of some identities in this chapter. Example number 1. Go and copy it down, and we'll start once you are ready. Go and pause it. So use the values secant of u equals negative 3 over 2, and tangent of u is less than 0. Find the value of tangent. Since they are giving us tangent of secant of u, and we're looking for tangent, we need to be able to find an expression that has secant and tangent. So therefore, I'm going to go through my formulas, and I'm going to go through the previous page and say, okay, I'm looking for secant because that's given to me, and I need to be able to find tangent. So secant, no, I have secant, but not tangent. I have cosine, so that doesn't help. I have secant, but no tangent. I have tangent, but no secant, no. I have tangent, but I don't have a secant, so I cannot use this one either. I'm looking for secant and tangent. No, no, perfect. We have tangent and we have secant. So I'm going to use this Pythagorean identity. We have tangent square of theta, of u actually, plus 1 equals to the secant square of u. And now what I'm going to do, I'm going to replace my secant of u with negative 3 halves. So now we have tangent square of u plus 1. Remember, the square is supposed to be outside, so it gives me negative 3 halves square. And now the only thing that I have is tangent, so now I can find the value of tangent by solving it. We have tangent square of u plus 1 equals to 9 over 4. 1 minus 1 on both sides, so move this to the right, we can say negative 1. I need to have the same denominator. So tangent square of u equals 9/4 minus 4/4. So therefore, tangent of square of u equals to 5 over 4. I'm not going to take the square root to solve for tangent. So therefore, I have tangent of u equals the square root of 5. Square root of 4 is 2. But I'm missing something, right? Every time we take the square root, we need to have a plus or minus. So I need to decide whether my answer is positive or negative. I'm going to make an x and y axis for secant is negative. Secant is the reciprocal of cosine, and that's your x value. So I know that's positive, that's negative. So it has to be either on the first quadrant, excuse me, on the second quadrant, or on the third quadrant, and that is for secant, negative. And to tell you the tangent of u is less than 0, which means it has to be negative. Now, where is tangent negative? Tangent is negative on which quadrants? Correct, the second and, well, they tell you the tangent is negative, so automatically that should be negative. But we usually have to say this is negative, so actually they need to do that part. But most of the time they'll tell you that you'll have to go through a process to be able to determine which quadrant is located. It's already negative, so I know that's negative. Now, I'm not sure if you remember, but we've done this type of problem before. Before, the way that we did it, we said, well, you know, secant of u is equal to negative 3 over 2. So therefore, the cosine of u is equal to negative 2 over 3. Since it's the reciprocal, then we make a quick, let me make it 3 by 3. We do need to make sure that we place it in the right location. In this case, we know that secant is negative and tangent is negative. So therefore, it has to be on the second quadrant. We're going to place our triangle here. And we have adjacent over hypotenuse. So it'll be negative 2 over 3. Remember, your hypotenuse is always positive. And now we do a Pythagorean theorem. C squared is equal to a squared plus b squared. C is 9. Negative 2 squared is 4 plus b squared. 5 is equal to b squared. So therefore, b is equal to plus or minus the square root of 5. It's going up, so it should be positive. And therefore, the tangent of u is the opposite of our adjacent. Square root of 5 over -2. So either way, you end up with the same answer. Now, sometimes in your SBAC, they prefer for you to solve it this way. So you'll have to be able to remember at least your most basic Pythagorean identity, which is sine square plus cosine square equals 1. So we've done it before like this. This is the new process that we learned today. Now, on this chapter, we need to be able to simplify and confirm identity. So first, we're going to simplify some expressions. Go and copy it down, and then we'll continue once you are ready. So I need to be able to simplify these expressions. Now the challenge is that we don't know what it should be simplified to. So our first strategy is to be able to change everything to sine and cosine. Change to sine and cosine. So that's our first strategy. Well, sine, it's already sine. Secant, I know that secant is the reciprocal of cosine, so I can replace secant to 1 over cosine of x. Notice that I take the time and the space to make sure that I place it on the denominator. I'm going to place my sine over 1 right away to make sure that I don't mix the numerators and denominators. And I want to change my tangent to sine and cosine. We know that our tangent is sine over cosine. So I'm going to change everything to sine of x over cosine of x. I'm going to multiply this out, and I'm going to change my division to a multiplication by taking the reciprocal of this fraction. So sine times 1 gives me sine of x over 1 times cosine is cosine of x times. I change it to the reciprocal, so it'll be cosine of x over sine of x. And now that cancels. This cancels, so we end up with 1. So we simplified it. Remember, the first strategy that we have is to change everything to sine and cosine. And one of the things that you have to be careful is whenever you change secant to 1 over cosine, you want to make sure you keep your sign on the numerator as part of that section. And you can place a 1 underneath to make less errors. Letter B. Our first strategy is to change everything to sine and cosine. So I change this. Cosecant is the reciprocal of sine, so therefore I can change it to 1 over the sine of t. Minus, this is already cosine of t, times cotangent, I can change it to, correct, cosine over sine. So cotangent can be replaced to cosine over sine. I'm going to place this over 1, just like we talked about. So now I have 1 over the sine of t minus cosine of t times cosine of t gives me cosine of t squared over the sine of t. So we have two fractions, and we are lucky because they have the same denominator, so therefore we are going to add both fractions. The denominators will stay the same, and we end up with 1 minus cosine square of t. Now, 1, every time you see a cosine square and a 1, or a tangent and a 1, secant and a 1, sometimes every time you see something square, that should direct you to your Pythagorean identities. So I'm going to use this one here. We have sine square of u plus cosine square of u equal to 1. I'm going to move the cosine to the right, becomes a negative. So therefore, sine square of u is equal to 1 minus cosine square of u. So therefore, I can replace cosine square of u, excuse me, 1 minus cosine square of t with sine square of t over sine. One of the signs cancel. So therefore, this is equal to the sine of t. Notice that throughout the process, I'm working vertically to get to my answers. I'm never going sideways. So I never place an equal sign here and then place the result here. You always want to be able to work down. Even if you need more space, make a little more space. Example number 3. Simplify. So now we can change everything to sine and cosine, but in this case, it's already sine and cosine, so that doesn't help us. We also need to be able to know how to multiply and to factor out a common factor, a common term. So we notice that they both have a sign. So now I'm going to factor out the sine of x. And what's left behind? Sine of x times cosine square of x. Sine of x times what gives me negative sine will be minus 1. Once again, we have the cosine square of x minus 1. What is this equal to? Well, if I write down the sine square of, let's say, x plus cosine square of x equal to 1, which you should have memorized. I want my cosine to be positive and my 1 to be negative. So therefore, I'll move my 1 to the left, and therefore I must move my sine to the right. So I have cosine square of x minus 1 equal to negative sine square of x. So therefore, this sine of x, and this becomes negative sine square of x. Sine times sine gives me negative sine to the third power of x. So the challenge is that you're not too sure what your end result should be. As we verify identities, it'll be a little bit easier for the next section. But for now, you just have to trust and see where it gets to. So in this case, we factorize sine. In this one, what should we do? Correct. We should multiply the sine. So we have sine of u times sine of u will give me sine square of u. Sine of u times cosecant of u gives me negative sine of u cosecant of u. Now, we don't want to factor it out because that way we end up with what we had before. But we can change everything to sine and cosine, and I can change my cosecant to 1 over sine because that's the reciprocal of sine. Remember, I'm going to place this over 1. And the signs cancel each other out. So therefore, the sine of square of u minus 1 is equal to, so if I move the 1 to the left, the cosine will be negative cosine square of u. So just be careful. You can quickly do it in your head or go through a process and rearrange them so that way you can correctly replace it. Example number 4. On example number 4, you need to be comfortable factoring trigonometric expressions. So copy it down and we'll start once you are ready. And we factor on section 10.4, or excuse me, 10.5, what we need to solve. So in this case, we have the trinomial, 3 terms. You can rewrite it if you want. You can replace the tangent as just x. So we will have x squared plus 2x minus 3. And you can go through a process and factor it out. But I prefer if we actually just factor out from here. What are the factors of tangent square of x? Let me make a little more space and go next to the line. Factors of tangent square of x will be tangent of x and tangent of x. Factors of 3 will be 3 and 1. 1 positive, 1 negative, so this will be positive, and that should be negative. And that works, right? Because we end up with tangent square of x. Negative 1 and positive 3 will give me the positive 2 that I need, and then minus 3. Letter B. We have 1 minus cosine square of theta. This is called, do you remember the name for this special factors? The difference of two squares. So double parentheses. Factors of 1 will give me 1 and 1. Factors of cosine will give me cosine of theta and cosine of theta. 1 negative and 1 positive. It gives me 1. Positive cosine and negative cosine cancels out, and negative cosine squared. And you should recognize this as the difference of two squares, and this will come up often. We have 1 minus cosine of theta, or 1 minus cosine square of theta. Letters C and D. So let's go and factor this out. We have 3 terms, so nothing to factor out. There's no common factor, so we can just use the double parentheses. Factors of 2 sine square of u will be 2 sine of u multiplied by sine of u. Factors of 12 can be 3 times 4, 2 times 6, 12 and 1. I need to end up with 5. So which one should I use? 4, 3, 6. Correct. So that should be 4 here, because that gives me 8, and 3 here. So that will be positive 8, and negative 3 will give me positive 5 that I need. How about the next one? See if you can work out the next one. We have 4 terms. 1, 2, 3, 4. How can I factor this out? Go and pause it. So correct. On this one, we can use by grouping, correct? I'm going to group the first 2 and the second 2. What can I factor out of the first one? I'm going to factor a cosecant square of alpha. What's left? Cosecant of alpha plus 1. What can I factor out of the next 2? A negative 3. So therefore, this is cosecant of alpha plus 1. Remember, those 2 should always be the same. So now I can group cosecant square of alpha minus 3 and cosecant of alpha plus 1. If this was a 4, then we can actually factor that out as the difference of two squares. Now, in chapter, which chapter was this? Chapter 4, we learned that we actually can factor this out. You remember how to factor this out. Cosecant of alpha, 1 negative, 1 positive. And this will be, correct, will be the square of 3, square of 3. Do I need an I? No. So it gives me, and so if I need to factor this again, I can. But for now, we can leave it as that for this chapter. Example number 5. Perform the addition and then we simplify. Go and pause it, and we'll start once you are ready. So I need to be able to add both fractions. In order to add fractions, they need to have the same denominator. So therefore, this is 1 plus cosine. Now I'll place in parentheses, since that it cannot be separated. So therefore, on the left, I'm going to multiply by the sine of x. And what I do on the denominator, I need to do on the numerator. And therefore, on the right, I'm going to multiply by 1 plus cosine of x. Now, my denominator, I'm not going to multiply it out. I'm going to leave it as that. Sine times sine will be sine square of x plus my denominator is the sine of x, 1 plus the cosine of x. This gives me cosine times 1 is cosine of x. Cosine times cosine gives me cosine square of x. But my denominator, I will be adding it. Or my numerator, I will be multiplying, but not my denominator. Because many times, something will cancel on your denominator. Now they have the same denominator, so now I can add the fraction. The denominator will stay the same. Do not multiply it out. We can if you need to later on. And now I need to be able to simplify this. Do you recognize anything? So notice that we have your Pythagorean identity. Sine square of x plus cosine square of x is equal to 1. So I can rewrite this as 1 plus the cosine of x. And now you can see it, right? The sine of x, 1 plus the cosine of x. This cancels. So therefore I end up with 1 over the sine of x, which is equal to cosecant of x. Letter B is a typical problem that you guys will encounter several times in this chapter. I need to be able to add the fractions. In order to add the fractions, I need to have the same denominator. They're almost the same, but they're not. So on the right hand side, I'm going to need a 1 plus the sine of theta and 1 plus the sine of theta. On the left hand side, therefore, I need a 1 minus sine of theta and 1 minus sine of theta. I'm going to multiply it out. Now, do you remember what is 1 minus sine of theta and 1 plus sine of theta? What is that called? That is the difference of two squares. Same thing that we cover here. So therefore, I'm going to multiply by 1, gives me 1 minus sine of theta. I'm going to multiply this out, and that gives me 1 minus sine square of theta. Plus 1 plus sine of theta, difference of two squares, 1 minus sine square of theta. Remember, this cannot cancel. But now that they have the same denominator, the denominator will stay the same. And now I can add them. 1 plus 1 is 2. Negative sine plus sine is 0. So they cancel out. And what is the denominator equal to? So once again, I'm going to switch my sign to the right. We can say negative. So that will be equal to cosine. So this is 2 over cosine square of theta. Now, I'm going to separate this, and I'm going to say 2 multiplied by 1 is the same, correct? So therefore, I'm going to separate this as 1 over cosine square of theta multiplied by 2. This is secant. So therefore, a will be 2 multiplied by secant square of theta. Example number 6, last example for today. Simplify. So in order to be able to simplify this, our first strategy is to be able to change everything to sine and cosine. Our second strategy is to be able to add or subtract fractions, but there's nothing to add, we only have one fraction. But I notice there's a 1 plus cosine of x, so therefore 1 multiplied by the conjugate, or just by 1 minus cosine of x, because on the denominator is going to create the difference of two squares. And on the numerator, I will multiply this out, so I have the sine of x minus the sine of x cosine of x. And I can replace 1 minus cosine of x with, if I move my cosine to the right, it's going to become sine square of x. So I have the sine of x minus the sine of x cosine of x. And this becomes sine square of x. And now I'm going to separate my fractions. So it'll be sine of x over sine square of x minus sine of x cosine of x over sine square of x. And now I can simplify. So it gives me 1 over the sine of x minus one of the cosines cancel. So in this case, one of the sines cancels. Here, one of the sines cancel. So I end up with cosine of x over sine of x. And 1 over sine of x is cosecant of x. And cosine minus sine is cotangent of x. Now try the same thing with letter B. See what you get, and then we can compare our answers. You got it? So I'll multiply by the conjugate. 1 plus the sine of y. Notice that on the denominator, I'm going to end up with 1 minus sine of y squared. So I'm not going to multiply my numerator yet, because I have a cosine of square of y. So you want to kind of think ahead. So it gives you 1 minus sine square of y, which becomes cosine square of y. And that's why I'm not going to multiply it out, because that's going to cancel out. So if you're able to kind of see ahead and think ahead, it might save you a bit of work and quite a bit of headaches. But you do need to show me the steps throughout. You cannot jump from 1 all the way to the very end. Even if you see it in your head, I need to be able to follow your steps. So even if this cancels, you need to be able to rewrite things down. And this becomes 1 plus the sine of y. This will conclude the lesson for today. Have a good day, and I'll see you next time.